Good morning, children. In today's class, we are going to learn some theory questions which we had already discussed, but anyhow, according to the exercise, let us see some answers. Exercise 6.1, 11th question, define a random variable. What is a random variable? It is a real valued function defined on a sample space S, and it takes values in minus infinity to plus infinity, the interval, or numerical outcomes of a random experiment. So which are the key words? It's a real valued function. The domain is the sample space and it takes values from minus infinity to plus infinity. 12th question. Explain what are the types of random variable. There are two types of random variable, which is discrete random variable and continuous random variable. Question number 13. Define discrete random variable. Discrete random variable assumes finite number of possible values or an infinite sequence of countable real numbers. Putting together, you can remember either finite number of values or infinitely countable numbers. Two ideas we say, finite number of values or infinitely countable number of values. Example, marks obtained in a test or number of telephone calls at a particular time. So these are the ideas which we use for discrete random variable. Question number 14. What do you understand by continuous random variable? Continuous. So we will start a random variable x which can take any value in the interval. So discrete, it tells finite number of values or infinitely countable number of values. Here we say continuous random variable takes any value in the interval. Example, speed of a car, or I can say height of the people, weight of the people. These are examples for a continuous random variable. So whenever they ask you what you understand or explain or define, try to give examples. Question number 15. Describe what is meant by a random variable. We already defined here, this is definition. The same idea, but we give it how we understand it. A random variable is a function. The domain is set of possible outcomes. The range is subset of the real numbers. The domain is set of possible outcomes and the range is subset of the set of real numbers. Remember, random variable is a function. So three ideas we say here. It's a function. The domain is set of possible outcomes and the range is subset of real numbers. Question number 17. Explain the distribution function of a random variable. The distribution function we also call cumulative distribution function. Remember, the word cumulative tells me number below that value. How many of you got below 16? How many of you got below 70? That is the idea of a cumulative distribution function. We denote it as capital F of x. I said it is below. So how do you write it? P of x less than or equal to x. In PMF, we keep on adding till that value. If I say less than or equal to 5, till 5 I must add. So that is what we have written. Till that value, keep on adding. We tell sigma. The same idea when it is a PDF. Put integration from minus infinity to x, f of t dt. So the same formula, both the cases, capital F of x we say, which is p of x less than or equal to x. Explain or definition for any idea cumulative distribution function or probability distribution function, we say the same pattern. Here I put sigma, whereas here I put integral. Question number 16. Distinguish between discrete and continuous random variable. Discrete, we say finite or countably infinite number of values. Continuous, we say assumes any value in the interval. Here, p of xi is greater than or equal to 0 for every I. And here, instead of p, we use the notation f of x, which is greater than or equal to 0. Here we say total probability is 1, both the cases. Here I denote sigma pxi is 1, whereas here I denote integral minus infinity to infinity f of x dx is equal to 1. Here we say capital F of x as sigma pxi, where xi less than or equal to x. Here we say the same but with integral. So the same old ideas we discuss again and again. What all you know about discrete and continuous, you can tabulate. Here I call probability mass function. Here I call probability density function. Here we denote P of x, whereas here we denote F of x. Question number 18. Explain the terms probability mass function, probability density function, and probability distribution function. The same ideas we are going to redefine using better terms. X is a discrete random variable. And whenever I say discrete, it is finite or countably infinite. So put x1, x2, x3 and so on. Then the probability mass function, we shortly call it PMF. We denote it P of x. I can denote it in any way. P of x, suffix x I can put, or simply P of x, or pi, P of xi, all one and the same, and I will define it when x is equal to xi. That is, x is equal to x1, x is equal to x2, x is equal to x3, like that I can define. If x is not equal to xi, my answer is 0. And we have the two more conditions. P of xi is always positive or equal to 0 and total probability is equal to 1. The same idea we continue. For the continuous random variable, here I said discrete random variable. Here I say continuous random variable. The probability density function PDF we denote as f of x. It takes a value in the interval t1, t2, between 1 to 2, between 1 to 10, between 0 to 5. So we give the idea t1 to t2. This interval can be a closed interval or it could be an open interval. If it is open, we put only less than. If it is closed, we put less than or equal to. That is the only change. And this is defined as probability of x between t1 and t2 is nothing but integral t1 to t2 f of x dx. Here again we mention f of x is greater than or equal to 0 and minus infinity to infinity integral f of x dx is equal to 1. The distribution function already we discussed, capital F of x, which is nothing but P of x less than or equal to x. For discrete I put sigma, whereas for continuous I put integral, and that is the answer. Question number 19. Properties of discrete and continuous. First of all, we define P of x is equal to xi when x is equal to xi. If it is not equal, my answer is 0. And P of xi is greater than or equal to 0. Sigma I equals 1 to infinity, P of xi is 1. When I come to continuous, Here we define at x is equal to xi. But in continuous, it is in an interval. It is in an interval. So at any point, my answer is 0. P of x is equal to a is 0. Whereas, if it is from a to b, however I write, less than or equal to, or simply less than, or one side less than or equal to, or here, all the four are same and they are equal to the single integral a to b f of x dx. The same old idea, f of x is greater than or equal to 0 and integral minus infinity to infinity f of x dx is equal to 1, where x is between minus infinity to plus infinity. Question number 20, state the properties of distribution function. So this question may come under 2 or 3 or 5. There are many properties. I have given you some easy properties to remember. We know capital F of x, which is nothing but probability of x less than or equal to x. The value is probability being added. So, total probability will come or minimum probability 0. It is not negative. So, my answer is between 0 and 1. Remember, capital F of minus infinity, the least value 0. Capital F of plus infinity, the highest value, adding everything becomes total probability, that is 1. F of A and F of B, when I compare, if A is less than B, either they will be equal or A less than B tells me F of A less than F of B. So we write an important condition, F of x is a non-decreasing function and small f of x and capital F of x. What is the link? Capital F dash of x, that is derivative of f of x, we call small f of x. Derivative of capital F of x, we call small f of x, and it is always positive or greater than or equal to 0. So, combining this result and this result, P of x between a and b. Notice we wrote integral a to b f of x dx in continuous random variable. The same idea, if capital F is known, the formula is rewritten as f of b minus f of a. So exercise problems which we had already seen, we have come across. Small f tells me integrate between a and b. Capital F tells me just substitute upper minus lower, f of b minus f of a. Try to remember at least 5 properties to attempt even a 5-mark question. If it is 2 or 3 marks, at least remember to write 3 or 4 properties. Question number 7, exercise 6.2. Properties of mathematical expectation. So already we discussed in the introduction, we are just listing out the properties. Expectation of a constant is constant. Expectation of ax is keep a as it is expectation of x. Expectation of ax plus b is a e of x plus b, where a and b are constants. X greater than or equal to 0 implies e of x is also greater than or equal to 0. Variance of a constant is 0. We denote v of a equals to 0. V stands for variance. Variance of ax plus b is a square variance x. This explanation, it's given in the previous class itself. Question number 8. What do you understand by mathematical expectation? So expectation is nothing but average value of a random phenomenon. So we already said it is derived from gambling. So we say average winnings at a game or average profits of a product. So the average value of a random phenomenon is termed as mathematical expectation. So the main word, we say average value. And what phenomenon? It is a random phenomenon. And give some examples. Question number 9. How do you define variance in terms of expectation? Variance is nothing but expected value of x minus e of x the whole square. Expected value of x minus e of x the whole square. We write like this way, e of x minus e of x the whole square. Or else simplifying e of x square minus e of x the whole square. This we use in problems, whereas the definition gives only this formula, e of x minus e of x the whole square. Question number 10. Define probability. Question number 10. Define mathematical expectation in terms of a discrete random variable. X we call discrete random variable. P of x we call probability mass function. PMF in short. E of x is nothing but sigma x into P of x. The same idea if it is a continuous random variable. Question number 11. F of x we use for probability density function, and e of x is nothing but integral. Here I put sigma, whereas here I put integral, minus infinity to infinity. Here we put x into p of x, here we put x into f of x. Whenever integral comes, remember to put dx. So these are the theory questions in chapter 6. Learn the theory to attempt 2 or 3 mark questions very well. Thank you.